Hello, good morning everyone. Hope you're fine, hope you're well. Today we're going to be looking at similar shapes. Now, similar shapes involves three different bits. So we're going to go through each one at a time and take it from there. This is going to be possibly a long video. I may have to split it into two, okay? Similar shapes, what are they? Think about it. 5, 4, 3, 2, 1. Yes, similar shapes are shapes where the angles are the same and all the sides are in the same ratio. So remember that. At the most basic level, we may have something like this. And we may have an enlargement, because remember, it is enlargements that produce similar shapes. So, if this is that, I can find what we call the length spelled like that, right? Length scale factor. And the length scale factor is going to be really, really important to solve these kind of questions. So, we can see that 8 divided by 2 is 4. Or 24 divided by, it should have been a 24. That should have been a 12, even better, right? 12 divided by 3 is 4. There we go. So, all the sides are in the same proportion, the length scale factor is 4. And you need to be able to find that in order to answer questions. So, at the most basic level, one question might be, as follows. So we've got and they may ask you to find that missing length there. Well, it's going to look at my two shapes and go, well, the length scale factor is, I need to find two corresponding sides. So two of the matching sides between the two shapes is that one and figure out the length scale factor. So 15 divided by 5 is 3. Therefore, that missing side there is going to be 9. And this is how you will have to answer the question in the exam. Sometimes you may have to do it the other way. Sometimes you may have to find a missing side on the smaller shape. It is no problem. You're going to do it in exactly the same way. We are going to find the length scale factor between the two shapes. So again, find two matching sides, in this case 36 and 6. So the length scale factor is 6. So now I'm trying to find the length of the shorter side, the smaller shape even. I know that that's 18, so if to go from here to there, I am multiplying by 6. To go from here to there, I am going to divide by 6. So this side here that I'm trying to find is 18 divided by 6, which is 3. And that would have been the answer down there. Okay, so that is at the most basic level, how to find missing sides between similar shapes. Now, this gets a little bit more complicated when you've got similar triangles, because of the way they present the question. So I'm going to go through a few examples here. This is turning out to be a long video, never mind. So, you may have these two triangles here. Now, these two triangles, by virtue of these two lines being parallel, these two triangles are going to be similar, because that angle there is the same as that angle there. They are vertically opposite. And this angle here, these are alternate angles, the lines are parallel, is going to be the same as that one there. And this angle here is going to be the same as that one there. So I do have two similar triangles. So if they tell me that I don't know. If they tell me that, and then they tell me that, and they ask me to find those two sides, for example, I have to find two corresponding sides between the two triangles. So in order to find the length scale factor, which is how you should always begin these questions. Now remember, I know this side here in the big triangle, and that's between the angle that I've marked with one line and the angle that I've marked with two lines. So that side is corresponding to that one there, not the 7. This triangle is, I have to rotate it sort of in order to make it match the big one. The 3, the length of the side, that is between the 1 and the 2 angle is 3, which is corresponding to this side here because it's between the angle I've marked with one line and two lines there. So the length scale factor is going to be 21/3, which is 7. And now that I've got the length scale factor, I can find this side here. So this is going to be 12 times 7, which is 84. Hopefully, I haven't made a mistake. And then this side here is going to be 7 times 7, 49. So that's the only tricky bit with these kind of triangles where, you know, they give it to you like that. But hopefully, you just go forward with your drawing and you have it there. As usual, you should be taking notes of all these examples and making sure you annotate as we go along. The final kind of question that you may get with similar triangles would be if you get something like that. So they may give you some information, not necessarily all the sides, but some. So maybe this is 10, maybe this is 6, or maybe this is 5. I'm just making the numbers up. And maybe they ask me to find that, maybe they ask me to find that, and maybe they ask me to find only that. Now I need some information here, so maybe that. Okay, good. So the best way to think about this question, I think, is to kind of see that this is one triangle that has been superimposed on the other one. So I've got a smaller triangle, the one at the top, which is 6, 5, 10, and then I've got a bigger triangle where this is 30 and I don't know these two sides. Okay, that's kind of the best way to see. I've kind of merged them to, well, they've been merged on top, and what I've done is separate them just to see things a bit more clearly. So the length scale factor, remember every question, we've got to find the length scale factor, we've got to find two corresponding sides between the two triangles. 30 divided by 10 is 3. you always have to find the length scale factor. Now, they asked me to find that length there, which is that length there. Well, that's easy enough. It's going to be from here to there. From here to there, I multiply by 3, so from here to there, I'm going to multiply by 3 as well, is going to be 15. So that side there is 15. And then in the next bit, you have to be really careful. Because here, they were only asking me to find that side, just this length here. So what I can do is find all of that length, which I know is going to be 18. But that means that that's 18. So all of this here is 18. But they didn't ask me to find all of that. They only asked me to find that. So that bit there has to be 18 take away 6, which is 12. And that, in a nutshell, is similar triangles. So there's quite a few things going on. So at the most basic level, you've got two similar shapes, and you have to find the length of corresponding sides. Length scale factor, easy. When you've got triangles, you may have the slightly more complicated case where one triangle is on top of the other, rotated. Something happened there. And then the other case is when one triangle is superimposed on the other, and it's easier to split them apart. So I'm going to leave it here, and then I will do a different video on similar 3D shapes. Good luck.